Hello everyone, and thank you for watching this presentation. First of all, I would like to thank the following people for making this slideshow possible. Today's topic is 5G as enabling technology for building cities resistant to natural disaster. First of all, we ask ourselves the question, what is 5G? 5G is the term used to describe the next gen of mobile networks beyond the 4G LTE mobile networks of today. As the name goes, it is the fifth generation wireless, latest iteration of cellular technology engineered to greatly increase the speed and the responsiveness of wireless networks. Now, how is 5G better than the 4G that we use today? The next generation of wireless networks, 5G, will address the evolution beyond mobile internet to massive IoT, Internet of Things, for the horizon 2019 and 2020 to come. The main evolution compared with today's 4G and 4.5G LTE advanced networks is that beyond data speed improvements, new IoT and critical communication use cases will require new types of improved performance. The 5G technology is driven by 8 specification requirements. The first is to have data rate of up to 100 gigabits per second from the normal 4G or 4.5G networks that only has a data rate of 10 gigabits per second. It also offers a latency of 1 ms or lower for users that require real-time feedbacks. Increased bandwidth of more than 1000 bandwidth per unit area and connecting more than 100 devices per unit area. And now, what are the challenges that 5G faces? 5G demands much higher data rate, ultra-low latency, and a high reliability and security. A good example of something that uses 5G networks is VR, virtual reality. The first challenge are frequency bands. The current LTE systems operates with more than 5 frequency bands, which are below the 3.6 GHz range. One of the frequency candidates for early deployment of 5G is a sub-6 GHz range. Unlicensed spectrum below 6 GHz will be used for the first generation of the 5G network. The second challenge is accommodation for the huge data volume. Each network has to support huge volume of data since many applications capable of high-resolution video calling, live streaming, and downloading. A good example for an application for live streaming would be twitch.tv, where content creators publish their videos online for their fans to see. The new media trend is also towards video standard, and there is huge demand for video contents compared to conventional text form. A good example of this would be YouTube. Other examples of applications that need a high-speed networks for better user experiences: multimedia gaming, augmented reality, AR, and virtual reality VR. The third challenge is ultra latency service, and this is required for mission-critical applications and self-driving cars. This is to ensure that it has smooth operation, because any delay could cause an unexpected and devastating result in both situations. For example, Tesla in today's world, which is a self-driving car, uses an autopilot to drive the car, and if there's a delay in its autopilot, it would cause a devastating result. Other examples are emergency services and applications requires highly reliable network to immediately trigger warning during critical situations. Health monitoring devices, remote patient care devices, fire and rescue services require wireless networks to communicate, either self-activation from devices or initiated by users. 5G technology will achieve its expected high efficiency using most modern modulation techniques and network terminologies like carrier aggregation. Carrier aggregation is a technique used in LTE Advanced to improve the system efficiency. In carrier aggregation, 2 or more carrier signals are aggregated to support wider bandwidth, which allows even up to 100 MHz. Another example is small cell concept. In order to increase network efficiency, the cell is subdivided into microcell and picocells. Spectrum reusability allows to adding more users in a small geographical area and handle network more efficiently. The MIMO concept is a transmission technology with the usage of multiple antennas for transmission and reception. Simultaneous data transfer is possible using this technology, thus offers efficient data rate. The more the number of antennas, the more transmission and reception can be done. Now, Wi-Fi offloading. Wi-Fi offloading is one of the main features of the future networks. It allows the user to connect using Wi-Fi network and the cellular network can be allocated to other users. This can be suitable for some places where cellular network quality is poor and users still have the option to connect to the network without a cellular reception. Now, device-to-device communication, also known as D2D communication, is a technique where network authorized two adjacent devices communicate with each other directly. Network will have the control over the device and allows an operator to determine the traffic routing between direct and the network path. During the absence of network, one device can connect to another device. Cloud or radio network access. CRAN is a network technology used for effective communication with a centralized information processing carried out remotely within the cloud system. The signal will be processed at a remote location and the base stations will be connected with most efficient fiber optic connections. It gives lots of advantages in system implementation and maintenance and makes it highly efficient. Medium access control of 5G can be used to prevent natural disasters by focusing of frame-based scheduling and proposed scheme frame-based directional MAC. So when there is a detection of natural disaster that might happen, it will transmit it directly into the network. It will be put into a prioritized location to the PNC. This way it makes it more efficient since it is a prioritized wave or a prioritized packets. Now, the quality of service provisioning 5G. On the client side, there are 5 software modules. An example would be Mobile Quality Policy Based Router. On the other side, the policy router includes 4 software modules as follows. This is how quality of service provisioning 5G can be used to prevent natural disasters. The software that is working together of the RATCCSM and the MCCSM makes the module to provide the information. This module makes it able to prioritize a module, and then it will be carried out to the client side, and it can be in form of a signal or a radio that will be spread out for the whole city to be warned for that there is a natural disaster going to happen. This way people can be evacuated much more quickly. Now, the energy efficient mechanism. 5G network architecture will be using software-defined networks and network functionality virtualization, as shown in the diagram on the right. This is how energy-efficient mechanisms can be used to prevent natural disasters. The architecture for 5G communication systems are using functional virtualization and hardware normalization on the network side. This helps to lower access delay and makes it much more reliable to send a precaution message. So if there is an indication of a natural disaster occurring, the architecture will be proper cooperation between newly developed core network and the radio access network to be able to send the important and urgent information as quickly as possible.